If you've already programmed in some other language, variables in C are going to look very familiar. But to remind you, a variable is really just a named place in memory to store some specific type of information that you can read or manipulate at a later time. Here's an example of how you might declare a variable in C. It starts with the data type that indicates what general category of information this variable is going to hold. Then comes the name, which is of your choosing. Just make sure that you're very specific about how you name your variables because it is case sensitive and has to be exact. The C convention is to use lowercase letters and underscores in place of spaces. And then you want to finish with the value. You don't have to start every variable with a value already stored inside of it, but a lot of times you will. By putting the equal sign and then an actual piece of information that matches the data type, well, that's going to make a box in memory and then place this information in there. However, because it's a variable and can vary, you can change that information anytime you want, as long as it's within the same category of data. There's a few different categories of data that you can use in C, but here are 4 of the primitive types. These are the most basic and probably the ones you'll use most often. For example, char or character can hold a single character, and it only takes up 1 byte of memory. We'll talk more about what bytes mean, but that means it takes up a pretty small piece of information in order to store whatever value you want. Then comes int. Int can be any single number with no decimal places from around -32,000 to +32,000. And it takes up 2 bytes of memory. So you're going to want to use this pretty much anytime you have a single number to, say, count up. Then comes the float type. The float type allows you to have a number with decimal places. And in order to do that, it does take up 4 bytes of memory, meaning it's twice as big as an int. So make sure that you use it when you know you're going to have more precision. And then finally comes the double. In C, double is 8 bytes of memory, meaning it's twice as big as a float, but it gives you a much larger range to work with. So when you're picking your data types, especially on embedded devices because the memory is so limited, try to be judicious with which one you pick and try to pick one that is going to waste the least amount of space. C also has a very special concept of what we would call pointers. A pointer is not itself a value, but it is a type of variable that points to another variable, meaning it's a variable's address in memory. You can kind of think of it as a stored contact. You know how to go find that person. You're not actually storing that person in, say, your contact list. This enables you to create a smaller piece of information that can reference a large piece of information. And you can pass that small piece around to multiple functions so you can continue to manipulate that overall piece of information, but you're saving yourself memory because you're just passing around how to get access to it. Let's look at an example. Let's say we declare a variable of type int that stores the value 10. Then I want to create a pointer variable, and the way that I do that is with the asterisk or star character before the name. So that's going to be a pointer that can specifically point to any int variable. Then I'm going to set it equal to not 10, but the address of where my variable 1 is in memory. And I'm going to do that with the ampersand or and character. This is the dereferencer, and what it means is go into memory and find the exact address of where this thing is. That's what I'm storing, not the item, the address. You can picture this like so, where you have a box that represents the actual location in memory for your information. That box is labeled variable 1, and it stores the 10 in it. But then that second line creates a second variable var2 that just points to wherever that is. So if you use var2, you'll always be able to access the 10 stored in var1. If we want to look at this even more specifically, we can print out the dereference to each of those variables to see their specific location in memory, which C uses hex codes for. So you'll see a collection of letters and numbers that show exactly where the computer is going to find this piece of information. So the resulting output of this, you can see that the location in memory is exactly the same because var2 just holds the location of wherever var1 is. There's also a concept of void the void data type, meaning essentially no data. When are you going to want to use no data? Well, first, maybe you have a function that doesn't return anything. It just takes stuff in and then does some work, but it doesn't actually return anything out. Or maybe you have a function that doesn't take in any parameters. In C, you have to tell the function, hey, there's no parameters for you to take. And finally, if you do want to create a pointer, but you don't care about what data type the object is, well, you can make a void data type that just holds its location in memory as opposed to its actual specific data type. If you've ever programmed before, variables in C function very similar to pretty much any other programming language. You'll notice as we move through the course, we'll clarify when you might have certain pieces of code that look familiar or don't look as familiar. But overall, if you already know how to use variables in, say, Python, Java, or C#, you'll know how to use variables in C.